we are going to start with module number 5, that is differential amplifier. So in differential amplifier, basically, actually this is wrong. This is not negative feedback. It's actually something else. It's differential amplifier actually. So in differential amplifier, we are going to study different types of differential amplifier. All right. Then we'll see what is single-ended and differential signaling. Then we'll see the various terminology and quantitative description regarding the differential amplifier along with its DC transfer characteristics. Then what do you mean by differential gain, common mode gain? How do we calculate CMRR? Then the AC and the DC analysis of DFAM. And then we are going to touch upon a very important topic on current mirrors. Now, current mirrors are the basic horsepowers of analog electronics. So, for example, let's say a voltage divider bias is there. We have four resistors in it, right? So, an amplifier, which we have studied since last 2 months. So, let's say if we consider a MOSFET amplifier. Now, for a MOSFET amplifier to bias it in the proper operating region only, we require this four external resistors. All right, which are powered by single power supply. This is R1, R2, all right. This is RD, RS. And then we apply the input over here and we'll take the output by the bypass capacitors with the help of bypass capacitors and coupling capacitors. Correct? So normally in integrated circuit, we don't prefer resistors because it will occupy very large space. So in an integrated circuit, a resistor will look, its layout will look something like this. A turpentine structure. So it will occupy a large area on a chip. So that's why we don't go for this type of biasing. All right, we don't go for this type of biasing. We go for current mirror biasing. Okay. So in order to amplify the signal, we don't use resistors. Basically, we use MOSFETs only. So that's why this one who is interested in analog VLSI design and digital VLSI design should know about this current mirror. They are the basic thing which we start from, and also the DFAMs. All right. So now let us begin with differential amplifier. So you all can write down along with me. These are the basic fundamental concepts. Differential amplifier. So first we'll understand what is the difference between a differential amplifier and a normal amplifier. Then we'll answer the question why we go for differential amplifier. All right. Now, um, let's consider this a normal differential amplifier, normal amplifier, what it does. Let's understand that. So let's say this normal amplifier will have a gain of 100, let's say. Okay. So we have an output port and here we have input port, single input actually. So we connect it to the AC source. This will be V in. Now this will be in will be a time varying small signal. So this will be V in of T. Yes or no? And here we have the ground, we can say, and output also is with respect to ground. This is plus minus V out, and this is my load. Agree? And we power it with the supply, VCC supply. All right. Now let's say what the job of this amplifier is. The job of the amplifier is to amplify the signal. So you will get this type of V out signal. Yes or no? Agree on this? Correct. Now this input is called as single-ended input. This is single-ended input. That means there is only one input. Let's say this input is over here, very small signal, which is around 20 millivolt peak to peak. All right. And in this small domain, let's say if noise enters this domain and noise signals are very low frequency, very low amplitude. So let's say this is 5 millivolt. So this will get added to this. So what is the new input now? Instead of 20, the amplifier will see the input is 25 millivolt, and that will be accordingly reflected at the output. So let's say if we are supposed to get 2 volt at the output, because of noise, we will get 2.5 volt. For example, let's say we have two stages of this amplifier and the gain becomes 1000, let's say, and this amplifier, instead of giving us 2 volt as the correct output, it will give 2.5, which is the wrong output. Understood? So this is the problem of a normal single stage amplifier. So this is nothing but, let me write over here. Just a quick feedback. I mean, the audio and everything is fine.
Yes, sir.
Okay. So this comes under the category of single stage amplifiers. Now we'll answer the question why we go for, why DFAM, short form we call it as DFAM. Why we go for differential amplifier. So under single stage amplifier, so far we have studied BJT amplifier, right? In BJT we have studied common emitter amplifier, common collector, common base amplifiers, right? And we have also studied MOSFET amplifier in a syllabus. And MOSFET amplifier covered around common source, common drain, common gate amplifiers. All right. So all these amplifiers had single-ended inputs. Okay. So it was vulnerable to the noise signals. It cannot do anything about it. Okay. It cannot protect itself. Now, if the noise signal extra comes, it will corrupt the output, right? Now this is about 2 volt and 2.5. Let's say the signal range is very, very small. Let's say it's amplifying 0.5 volt or very, very even smaller. So that time the signal integrity will be affected. Okay. So that's one motivation for it. Okay. So now let's go for differential amplifier. Let's answer the question why we go for differential amplifier. Okay. So now let's consider a diagram of a differential amplifier. So let me draw a differential amplifier. How it is different than the normal single stage amplifier, we'll understand it now. So this is my differential amplifier. Okay, it has a gain AD, differential gain. It is also powered with supply, but instead of giving it to ground, it requires two power supplies, one positive and one negative. So negative supply will return as minus VEE. All right. And here, instead of one input, it has two inputs, dual input. All right. And instead of one output, it also has dual output. So V out 1 and V out 2. Okay. And this can be two inputs. So I'm representing it over here. So this is V in 2. This will be V in 1. Okay. Understood. So these are called as differential inputs. So this is differential inputs and you have differential outputs. So we have two outputs, right? So this we call it as differential output. Okay, so when we say output, that means it is V out 1 minus V out 2. We can have a single ended output also, that is V out with respect to ground, V out 2 with respect to ground. But V out is what? V out 1 with respect to V out 2. Now, now we consider the concept of the noise signal. All right. Okay. So, so far you have drawn this or are you drawing these things or just listening? So that I can accordingly wait or pause for you to draw. So can you tell me, are you writing these things?
Drawing, sir.
Done, sir.
Okay, okay. So accordingly, I'll take the pause and accordingly I'll explain because this is recommended that you also write along with me, whatever I'm writing over here. Okay. So in the meanwhile you're drawing, I'll explain the effect of noise now in the system. So let's say, uh, this V in 1 is basically, let's say 30 millivolt and V in 2 is, let's say 10 millivolt. All right. Now noise is present already. So let's say noise is coming from an external environment and influencing V in 1 and V in 2 signal. But this noise signal will contribute, let's say plus 5 millivolt to both of them. So 30 millivolt becomes 35 and 10 millivolts become 15. So that's the effect of noise, let's say external noise. So this is external. Sometimes we have internal noise also. So let me generalize it as noise signal only. The sources of noise can be different. That also we'll talk about in a minute or so. Okay. Now, ready? Let's say the differential gain is 100. ED is called as differential gain. We can call it differential voltage gain. All right. That differential voltage gain, let's say the value is 100. Now, what is the ability of differential amplifier? Differential amplifier amplifies the difference between the two input signals. So that means V out is equal to gain times it will amplify difference between the two signals V in 1 minus V in 2. So now what will happen is V out will become 100 times. What is V in 1? 30 millivolt plus, let me write it this way so that I can tell you the difference, plus 5. This is my V in 1 and then minus what is over here, 10 millivolt plus 5 millivolt. Yes or no? Here it is. So what will cancel out? Can you tell me? The noise signal which was there, it will cancel out itself, right? So noise which was present in both the input signals will cancel out over here easily. Yes, and what will be the answer? The the original answer was 30 millivolt minus 10 millivolt. That is what will be amplified. So differential amplifier amplifies the difference between the two input signals. So how much it will be? What is 100 into 200? How much this will be? This will be 2 into 10 raised to 3 into 10 raised to minus 3. So that will be 2 volt. Yes or no? Correct. Did you understand this concept? So noise is affecting both the inputs equally, and the function of the differential amplifier is such that it amplifies the difference between the two inputs. The noise signal also gets cancelled out. Agree? So that is why we use differential amplifier. And basically, the biggest application of differential amplifier or the areas which they are working under it is biomedical or bioelectronics, or we can call it biomedical electronics, where we are dealing with various biosignals such as ECG signal, then EEG signal. So these are the examples where we use a differential amplifier. Yes or no? Hello? A quick
Yes.
feedback from you all. Yeah. So now, what is this called as differential input? So this is called as V in D or just VD. These are called as differential inputs. So this differential input is nothing but V in 1 minus V in 2. And how much was it? This was around 20 millivolt, which was cancelling the noise signal. Okay, fine. Understood this? So do you know the actual how is the AC to DC signal is generated? Let's say that if you have 230 volt AC signal, 50 hertz. Yes or no? So how will you get a DC signal from it? Do you know that process? So first we have transformer stage. Yes or no? So that 230 gets converted into 23, let's say. Then you have a rectifier stage. You remember? So this is this signal. Rectifier signal will give you this, right? And then you have filter stage. So filter stage will give you the signal like this. Yes or no? And then you have a regulator stage, which will give you the final uh, output. I mean, we connect a load across it or something, and then we get a DC signal. So here we get a signal which is a DC signal. So while conversion of AC to DC, there is one source of noise. That is 50 hertz. Do you know AC signal can have harmonics? Have you encountered harmonics before? Harmonics. You have a fundamental component, it's harmonic components. Yes or no? Hello? So let's say this is the fundamental component and there can be its harmonic also present. So harmonic might be a low frequency signal. So these are harmonics. First harmonic, second harmonic. Okay. So these harmonics are, we call it as 50 hertz noise. Okay. To many of the digital microcontroller or microprocessors will require a DC signal to work with. So this signal, DC signal is generated from AC. And from an AC signal, this 50 hertz noise signal will be propagated also. Okay, so this is one source of noise. Understood this? Hello?
Yes, sir.
Okay, great. Have you noted down this or can I go on to the next part? Now we'll go for differential amplifier terminology. So can I go to the next part now?
Yes, sir.
Okay, so next please write down. We will discuss about differential amplifier, differential amplifier terminology. So the first term is over here, differential input signal. Please write along with me. Differential input voltage. So differential input voltage is determined by VD or VID, or it is also sometimes written as V in of D. Okay, differential input voltage. Can you tell me in this example how much is differential input voltage which I have showed you? In this example, how much was 20 millivolt? Yes, correct. This is the differential input signal. So now we will formally define it. So please write down the definition. If inputs V in 1 and V in 2, please write along with me. If inputs V in 1 and V in 2 applied to the differential amplifier, if inputs V in 1 and V in 2 applied to the differential amplifier are such that there exists either amplitude or phase difference between them, if inputs V in 1 and V in 2 applied to the differential amplifier are such that there exists either amplitude or phase difference between them, such inputs then such inputs are called differential inputs, are called as differential input. Okay, these points are important. Either having amplitude or phase difference between them. Okay, so that is how we define differential input. Now, I hope you have written the definition, right? Now we'll go for the formal definition. VD is equal to VID is equal to V in of D, all are one and the same, is equal to V in 1 minus V in 2. So for example, first case, let's say what they are saying, input V in 1 and V in 2 should be separated by amplitude or phase difference. So let's say V in 1 is 40 millivolt, V in 2 is 20 millivolt. So how much will be VID or VD? How much? 40 minus 20 millivolt, which is around 20 millivolt. So this is the example of amplitude difference. Yes or no? The amplitude wise, V in 1 and V in 2 differ each other. Yes or no? Now let's take the second example. Let's say V in 1 is 10 millivolt at 0-degree phase difference. And V in 2 is same magnitude, 10 millivolt, but it has a phase difference of 180 degree. So one signal is having the same amplitude, having the phase difference of 0 degree. So let me draw it. It will be like this. And other signal will have the same amplitude, but it will have a phase shift of 180 degree. Okay. So how will you tackle such a signal? So this is an example of a phase difference. Both are out of phase with each other. That means here VID or VD, can you tell me what it will be? It will be 10 millivolt minus of minus 10 millivolt, which is again 20 millivolt. Did you understand this? Why it is minus? Because it is out of phase with each other. Okay, this is your V in 1 and this is your V in 2. When you subtract them, you get a positive number, which is 20 millivolt in this case. So did you understand that how you should categorize your differential input voltage? It is that signal which will have either an amplitude or a phase difference between them. Then only you can categorize it as differential input signal or a voltage. Understood this topic? Anyone having any doubt?
No, sir.
Okay, all right, great. So let's go for the second definition. Let's go for the second terminology. So write down differential mode signal. Differential mode gain, sorry. Differential mode gain can be written as AD, denoted and noted in as AD or AVD. Differential mode gain. Okay. Now we'll define differential mode gain. So write down the definition. The gain with which differential amplifier amplifies amplifies the differential input signals, the gain with which differential amplifier amplifies the differential input signal, that is VID or VD, is known as differential mode gain. Differential mode gain. The gain with which differential amplifier amplifies the differential input signals is known as differential mode gain. So now we'll write the mathematical definition. So AD, it is denoted as AD, differential mode gain. It is V out 1 minus V out 2 divided by V in 1 minus V in 2, which can be written as V out differential. Here we can write it as V in differential, which can be written as VOD or VID also. Okay. So what is the first term over here? First term is called as differential output voltage. Yes or no? The first term can be denoted as differential output voltage, and the lower term, denominator term, is called as differential input signal, right? Differential input signal. Yes or no? Now, this differential input signal, this V in can be in microvolt also. So it can be 100 microvolt minus 50 microvolt. So what is my VID now? 50 microvolt. Okay. And which signals have the ranges in microvolt signals? See, ECG signal, which we have, okay, that is in low millivolt, maybe few millivolt, 1 or 2 millivolt. EEG signal, which is the brainwave signal, it is in microvolts. So if you want to amplify such small amplitude signal, we have to use a differential mode amplifier, which will also take care about the external noise. All right. So if this is very, very small and if denominator is very, very small, what should be the value of AD? VD will be in the ranges of volts, right? But this is in range of microvolt. So how much ideally, how much should be AD? Tell me. Ideally, it should be very high or very low. It should be very high. Ideally, it should be infinite. And practically, the value of differential mode gain should be very high. So if this value is very high, it can amplify the smallest difference between the two signals also. And that is the function of a differential amplifier. So a very good differential amplifier, what is the parameter of figure of merit which will indicate it should have a very high differential mode gain. Did you understand about this concept? Differential mode gain, everyone? Yes or no? Yeah, everything you're able to follow now?
Yes, sir.
Okay. Have you completed writing this? Shall I go to the next part?
Yes, sir.
Okay, great. So, whenever we complete 1 hour, we'll take a break of 5 minutes and then we'll continue again. So let's go for the third definition. Next, we write down common mode input voltage. Common mode input voltage. You denote it as VCM, or sometimes we also denote it as VICM. So let's write down the definition of common mode input voltage. Write down if inputs V in 1, comma V in 2 applied to the differential amplifier, I'm writing short form as DFAM, are of, if the inputs V in 1 and V in 2 applied to the differential amplifier are of same magnitude and phase, then such inputs such inputs are known as common mode inputs, are called common mode input voltage. Okay. Now mathematically VCM can be written as V in 1. So that means, listen over here. So V in 1 and V in 2 are of same amplitude and same phase. So that comes under the category of common mode input signal. So that means V in 1 is equal to V in 2. So this way. So let's say this is V in 1. So V in 2 also will be exactly the same. Okay. So how do we calculate V in VCM? VCM is V in 1 plus V in 2 by 2. Okay. So let's consider if V in 1 is around 1 volt and V in 2 is around 1 volt, how much will be VCM? 1 plus 1 divided by 2. That will be 1 volt only. Understood this topic? Common mode input voltage VCM or VICM. So if the inputs V in 1 and V in 2 applied to the differential amplifier are of same magnitude and phase, then such inputs are categorized as common mode inputs. Formally, VCM is V in 1 plus V in 2 divided by 2. Okay. Now there are two more definitions. Okay, the fourth one. I hope it is completed. The fourth definition is common mode gain. Common mode gain can be written as ACM or AVCM. These are the notations about the common mode gain. Okay, so write down the definition. The gain with which the differential amplifier amplifies. You all write the full, letter, differential amplifier. I'm writing the short form, but you all write it full form. So the gain with which differential amplifier amplifies the common mode signal. The gain with which differential amplifier amplifies the common mode signal is known as common mode gain. Is known as common mode gain. So let's consider and mathematically how we write ACM. ACM will be V out divided by VCM. V out is nothing but the output due to common mode signal. Okay, so this is due to V out CM upon V in CM. This V out is due to common mode component of input. Okay, ACM is common mode gain, and it is the ratio of output common mode signal divided by input common mode signal. Okay, so common mode signal we can categorize as one form of noise. So do you want to amplify the noise signal or reject the noise signal? We have two options. So ACM will be 0 ideally. Okay, because we don't want to amplify this noise signal. So practically ACM should be very, very small. It should be very low practically. So how good is a differential amplifier? How do you measure? If differential mode gain is very high and common mode gain is very, very low, because common mode gain is actually amplifying the common mode signal, which is the form of a noise. So we should reject the noise signal and amplify the difference between the two signal. Okay, I hope you have completed this. So ideally common mode voltage, common mode gain should be as low as possible, ideally 0. So a good differential amplifier will have differential mode gain very high and common mode gain very, very low. Now let's go to the last definition, that is CMRR. Now it's an acronym for common mode rejection ratio. CMRR is also called as common mode rejection ratio. Let's write down the definition. It is the ability of differential amplifier to amplify the differential mode signals, to amplify the differential mode signals and reject common mode signal. So it is the ability, CMRR is the ability of a DFAM or a differential amplifier to amplify the differential mode signal and reject the common mode signal. Okay. Mathematically also we can write a definition. So we can write it is the ratio of differential mode gain is the ratio of differential mode gain to the common mode gain. Okay. So mathematically, can we write this? So CMRR will be is the ratio of differential mode gain to common mode voltage gain. So CMRR is equal to AD upon AC. Okay. We can consider the magnitude of it. because sometimes your differential amplifier gain might be negative. So that's why we consider only the positive values. It's a mod sign. Now, normally CMRR value will be very, very high. So very high value can be brought to a lower value by writing it in decibels. So CMRR in dB will be given by 20 log to the base 10 mod of differential gain upon common mode voltage gain. So this is ACM, it's AD upon ACM. So this is the mathematical formula for a CMRR in dB. Okay. So ideally, what do we want the CMRR to be, very high or very low? Now, from the discussion what we had since the last hour, what do you think? Acha, first we want AD high or low? Differential voltage gain.
AD high.
Yeah. Next, ACM should be low, right? So if the numerator is increasing and denominator is decreasing, what happens to CMRR? Increases or
Increase.
decreases? Increase, na? Numerator is, the denominator is increasing. I mean, numerator is increasing and denominator is reducing. So overall CMRR will improve. And typical example ranges from 70 to 80 decibels. All right. So in short, we can say CMRR is AD upon ACM. ADS should be infinity and ACM should be going towards zero. So that's why the the CMRR should be infinite practically and very, very, sorry, ideally infinite, and practically it should be very, very high. So practically we can say this is ideally CMRR should be infinite. This is ideally, and practically CMRR value is around, should be around greater than very high value 80 dB. All right. Understood what is CMRR? Sometimes they can frame a question like this, that with respect to differential amplifier, explain the functioning of a differential amplifier, then explain what do you mean by differential input voltage, what do you mean by common mode voltage, what do you mean by differential signal, and what do you mean by common mode input voltage, or even what is CMRR, and explain its significance. So the significance of CMRR is it will distinguish between a very good differential amplifier and a bad differential amplifier. So a good differential amplifier will amplify the difference between the two inputs, and you know and will reduce the noise signal as much as possible. So it's basically a figure of merit for a differential amplifier. So a very good differential amplifier will have a high value of CMRR, whereas a not so good, the limited speed amplifier will have not have a very good CMRR. Okay, so completed this for five definitions related to differential amplifier. Now we go for types of differential amplifier. So write down types of differential amplifier. Okay, so basically there are four types of differential amplifier. We are only discussing MOSFET based amplifiers. Okay, MOSFET based differential amplifier. So the first is dual input balanced output DFAM, which is called as DIPO. Okay, second will be dual input unbalanced output differential amplifier, which we can call it as DIUO. Then there will be single input, balanced output, differential amplifier, which we can call it SIBO. And the last one is single input, balanced output, not balanced because single ended, balanced one is already covered. Single ended, single input, single input, single output differential amplifier. So that is SI or unbalanced output, basically we can call it. So single input, unbalanced output, differential amplifier. So here you can see very clearly, whenever it is written dual, it is D over here. And whenever it is written balanced over here, it is B over here. Similarly over here, it is unbalanced. So that's why they have written U over here. And here it is written single input. So that's why it's written S over here, SIBO. So the four types of differential MOSFET differential amplifier are DIBO, DIUO, SIBO, SIUO. All right. Have we completed this? Now we'll draw the structures and then we'll take a break of 5 minutes. So let's go for the circuit diagrams of all these configurations. So let us first concentrate on
Can I just go for
the,
1 second?
yeah. Okay, I'll wait. So depending upon whether the input is dual input or single input and the output is balanced or unbalanced, we have four categories of differential amplifier. Have we completed?
Yes, sir.
Okay. Now we'll one by one draw these configurations. So first we'll write down, uh, I'll write down the short form DIBO, DFAM. So let's draw it. So we are drawing MOSFET based. So I'll draw MOSFET based only. Okay. So over here, what will come? Two resistors will come over here. This is V in of 1. This is ground. This we have RD2, RD1. This is Q1 and Q2. Here we have one more resistor. Okay. And these two emitter terminal, I mean the source terminals are connected together and then connected to a single resistor along with the negative supply. This is plus minus V into, and this is R. We can call it RS1, RS2. Okay, the gate resistance. Yeah. What do you mean by dual input balanced output? Let me show it to you. So here balanced output means this is Vout1, let's say VO1 and this is VO2. Balanced output means in between them. We take it 1s plus Vout. Okay. So which one is positive? Let's say VO1 is positive. Then it will be VO1 minus VO2. So your Vout will be equal to VO1 or Vout1 minus Vout2. So this is my differential balance output. And for dual input, we have V in 1 and V in 2. Balance output means it's taken across both the collector terminal, the drain terminals. All right. Can we go to the next configuration? Okay. So configuration number 2, DIUO. So it will be entirely the same thing only. What will be the difference? Anyone can tell me? What is the difference? So this will be, actually this should go to plus VCC. So let's it plus VCC, and here we'll have V into RS2, RS1, this is V in of 1, and source terminal are connected together and connected to a resistor minus VEE. So this resistor we call it RE, this will be RC1, this will be RC2. Okay, so this configuration is DIUO. So how will you draw it? So here inputs are dual, but the output is single-ended, right? So I'll take from one of the arm and take it over here. This is VO2, which is your output basically. All right. One important caution to note over here is here V out was measured with respect to each other, VO1 and VO2. Here V out or V out equal to VO2, output is measured, output is measured with respect to ground. Okay, remember that this is measured with respect to ground, whereas in case of a balanced output, it is measured with respect to each other. All right. Can I go for the next one now, students? Completed this much?
So 1 second.
All right. So SIBO. So this is single input balance output. So the yeah. So the output will be as this, and the input will be only one applied. Okay, let me show it to you. So let's draw a differential amplifier again. So this is my differential amplifier. So this is plus VCC, RC1, RC2. We have one of the terminals connected over here as input. This is plus minus V in 1, and the other terminal is grounded. This is V in 2 is grounded. So this single input. Okay. And what do you mean by balanced output? This is RS. It's actually R instead of RE. No, it is RS only. Correct it as RS. So this is RS1, this is RS, and this will be minus VEE. Remember that. Okay. So what do you mean by balanced output? It's measured with respect to each other. This is VO1, this is VO2, and this is plus minus V out. So what is my output voltage? It's a differential balance output, but it is a single input. Okay. So this is the third category. Have you all completed this? This is the last circuit. Then we'll take a break. So the last circuit will be single input unbalanced output. So let's draw the amplifier, differential amplifier once again. All right. So this is my resistor RS. So here is plus VCC, RC1, RC2. This is RS1. This is plus minus V in 1. This is 0. V into is 0, and this is minus VEE. Acha, how will you show unbalanced output? Across only one of the terminals, right? So either this or this. So here let's show for this. So let's say this is VO2 and this is measured with respect to ground. So that's why it is called as an unbalanced output. Okay. So over here we have a single input instead of a dual input and an unbalanced output because this output is measured across one of the output terminals where the second output terminal is open. So here also VO2, that is output, is measured with respect to ground. All right. So yeah, that is all for lecture number 36. Now in 5 minutes time, we'll start with the lecture number 37. Okay. So I hope you have completed up till here. Let me stop the recording. So students,